Good morning, my dear student. On the behalf of KTGM College Nasik and Department of Chemistry of this college, I am Dr. S.R. Labhade, welcomes you to the lecture on polarographic analysis. Student, in previous 10 lecture we discussed what is voltammetry, principle of voltammetric analysis, electrode system employed in voltammetric analysis. In addition to this, we discuss what is polarography, principle of polarographic analysis, electrode system employed in polarographic analysis. We also discuss the construction, working, advantages and disadvantages of dropping mercury electrode, which is used as a working electrode in polarographic analysis. We also discuss the instrumentation of polarography and working of polarography. Furthermore, we discuss the results obtained in polarographic analysis, that is polarogram, and its application in qualitative and quantitative analysis of electroactive species. Furthermore, we discuss the factors affecting the nature of polarographic wave. We also solve numericals based on calculation of diffusion current, calculation of diffusion coefficient, calculation of concentration of electroactive species, and calculation of number of electrons involved in redox reaction. After this, we discuss the different applications of polarography, that is qualitative as well as quantitative applications, and we discuss the polarographic titration and types of polarographic titration and their applications. Student, in today's lecture we discuss some questions and their answers for preparation of university examination. First question, what is polarography? What is polarography? Polarography is a linear scan, linear potential scan, voltammetric method of qualitative and quantitative analysis of qualitative quantitative analysis performed in a quiescent analyte solution using polarized dropping mercury working electrode and non-polarized pool of mercury as a counter electrode. Polarography, that is the first invention of voltammetric method. Polarography is a linear potential scan voltammetric method of qualitative and quantitative analysis performed in a quiescent analyte solution using polarized dropping mercury electrode as a working electrode and non-polarized pool of mercury as a counter electrode. That means both working electrode as well as counter electrode in polarography are the mercury electrode. Next question, we discuss the principle of, explain the principle of, second question, explain the principle of polarography. Principle of polarography Polarography is a linear potential scan voltammetric method of qualitative and quantitative analysis in which an analyte solution is made a part of electrolysis cell. The analyte solution is electrolyzed using linear potential range. After electrolysis, a graph of cathodic current obtained because of reduction of analyte versus applied EMF tells us, applied EMF gives half wave potential and diffusion current. Which tells us what is in the solution, means qualitative analysis and how much it is, means a quantitative analysis. In this way, both qualitative and quantitative analysis is performed in a polarography, and you have to show this result in the form of polarogram, and that is like this. Here a reduction current in microampere versus EMF in millivolt gives a polarogram, a step curve showing residual current and limiting current. This is a ID directly proportional to concentration of analyte, and at half of the diffusion current, even half is the identity of the analyte. In this way, here you can show the result of polarographic analysis. This is a limiting current, and here this is a complete principle of polarographic analysis. What are the linear scan voltammetric method. What are the linear scan voltammetric method? First of all, you have to explain what is linear scan voltammetry, and after that you have to give the types of linear scan voltammetric method. Therefore, here answer of this question, the linear scan voltammetry are those voltammetric method in which the potential of working electrode is scanned either to positive direction or to negative direction in order to carry out oxidation or reduction of an analyte onto the working electrode. Therefore, linear scan voltammetry are those voltammetric methods in which the potential of working electrode is scanned, that is increased linearly either to positive direction where oxidation takes place or either to negative direction where reduction takes place on the working electrode. And here the voltammetric method in which potential is linearly scanned are of two types, and those are like this. Two types of linear scan voltammetry. First one is a polarography. We know that it is a linear potential scan voltammetry in which working electrode is dropping mercury electrode and perform in a quiescent analyte solution. Therefore, perform in a quiescent analyte solution using dropping mercury electrode as a working electrode. And second voltammetric method in which potential is linearly scanned, that is called as hydrodynamic voltammetry. This is a voltammetric method in which here it is performed in a analyte solution which is continuously in motion. Therefore, perform in a analyte solution which is continuously in motion, and it is performed by using a stationary electrode like platinum, gold, graphite or silver, etc. Therefore, in this case, polarography is a linear potential scan voltammetry perform in a quiescent analyte solution. Hydrodynamic voltammetry is a linear scan voltammetry, but it is performed in an analyte solution which is continuously in motion. One may ask what are the linear scan voltammetry and differentiate between polarography and hydrodynamic voltammetry. The main difference in polarography and hydrodynamic voltammetry: polarography is performed in a quiescent analyte solution and hydrodynamic voltammetry is performed in a solution which is continuously in motion. This is the basic difference in polarography and voltammetry. In polarography, analyte solution or analyte species are transported to the electrode surface by diffusion phenomenon, while here in hydrodynamic voltammetry, analyte species are transported to the electrode surface by convection phenomenon. That means solution is continuously stirred and analyte species are transported by mechanical means a convection phenomenon. Therefore, convection current is measured in voltammetry and diffusion current is measured in polarography. This is the basic difference between the voltammetry and polarography and hydrodynamic voltammetry. Student, the next question that is related with working electrode, and question is like this: what is the potential range? Question number 4. What is the potential range in which DME is used as working electrode for polarographic analysis? What is the potential range? We know that working electrode in polarography or in a voltammetry is a microelectrode. Microelectrode means dimension of these electrodes are very small. It ranges few square millimeter, and therefore with application of small linearly increasing potential, these electrodes are get easily polarized. But therefore here the potential range in which that act as a working electrode in case of dropping mercury electrode, that is plus 0.4 volt to minus 1.8 volt. Therefore, first of all we discuss working electrode. The working electrode in polarography is a dropping mercury electrode in which a small spherical mercury drop having area of 0.05 square millimeter is generated on the tip of capillary which is hang in the body of analyte solution, and act as a site for reduction reaction. Therefore, one may ask you what is working electrode in polarography. Therefore, you have to write the answer. Working electrode in polarography is dropping mercury electrode in which a small spherical drop of mercury having area about 0.05 millimeter square is generated on the tip of the capillary which is hang in the body of analyte solution and act as a site for redox reaction or reduction reaction. Therefore, here the potential range in which this DME is used as a working electrode the potential range in which DME is best working electrode is plus 0.40 volt versus plus 0.40 volt to minus 1.8 volt versus saturated galvanic electrode. This is a potential range in aqueous medium. If medium is changed, sometime range may be changed. In previous lecture we discussed this range plus 0.4 to minus 2.4 volt. That will be vary on the basis of the medium. That is whether it is aqueous medium or some organic solvent containing medium. Therefore here in aqueous medium the potential range is this. When potential is greater than is more positive than plus 0.4 volt, then oxidation of mercury takes place, and here the metallic mercury is get converted to mercurous ion. Therefore this is an oxidation. Therefore here potential range gain more positive than this, electrode itself undergo oxidation. Therefore we does not increase potential more than plus 0.4 volt in case of DME. Similarly, when potential is more negative than 1.8 volt, then when potential is more negative than minus 1.8 volt versus saturated galvanic electrode, then the electrolysis of water takes place. Electrolysis of water takes place and a hydrogen gas is generated at DME. Therefore here twice H plus 2 electron, this is a reduction that gives H2 gas, and therefore this reduction takes place when potential is more negative than this. Therefore only this is a potential range in which we can use this dropping mercury electrode as a working electrode.